Hello friends, welcome once again to Prismatis online class. In this class, we are going to look at the proof of what complex number. We are going to look at the proof of the product of polar/trigonometric forms of complex number. Trigonometric forms of what complex number. So we are going to look at it. So what do we do here? Let's say, given that Z1 equals to polar form of complex number R1 into cos theta 1 plus I sin theta 1, and Z2 equals to R2 into what? Cos theta 2 plus I sin theta 2. So the proof says that we should prove that Z is equal to what? Z1, Z2. The product of what? The two what polar form or two trigonometric form. So we got to prove it. We try to prove it and know how the result at the end what we are going to get. Okay, proof. Let's start. Proof. Now we have that Z is equal to 1. Z1 is what? R1 into cos theta 1 plus I sin theta 1. Close it. So we are going to multiply this into R2. Our R2 is what? And that is Z to R2 into what? Cos theta 2 plus I sin theta 2. Close it. So we are going to multiply this with this. So what do? We multiply R to R, which we have that Z is equal to R1 times R2 into what? Bracket cos theta 1 plus I sin theta 1 multiply by what? Another bracket cos theta 2 plus I sin theta 2. Close it. So we are going to multiply the inner what? Bracket and know what we are going to get at the end of the journey. And what do? Let's start. This is Z is equal to R1 R2 into bracket, big bracket, into bracket cos theta 1 multiply everything that is here, which is what? Cos theta what? 2 plus I sin theta 2. Close it. Plus I sin theta 2, theta 1, multiply everything that is here, cos theta 2 plus I sin theta 2. Close it. So now with this, now we can come up and solve this. Now what do we have here? We have that Z is equal to R1 R2 into big bracket. What do we have? Cos theta 1 times cos theta 2 will give us what? Cos theta 1 cos theta 2. Did you get it? Okay. Or let's just solve it here so that it will accommodate. Let's just solve it here. I'm through with this, but let's solve it here. Okay, let's continue up. Z1 Z equal to what? R1 R2 into bracket cos theta 1 times cos theta 2 will give us cos theta 1 cos theta 2. Cos theta 1 times I sin theta 2 will give us plus I cos before sin or sin before, it depends, or anyone you like. Somebody will like to say cos, okay, which is cos theta 1 sin theta 2. So this one times this one, that is the reason why we get this. Okay, plus I sin theta, which is if we have started with cos, let's say cos times this, we have it as cos theta 2 times I sin theta 1. I sin theta 1. Cos theta 2 times I sin theta 1 will give us what? Will give us what? Cos theta I sin theta what? 1. Okay. Plus I times I will give us I square. I square. Now sin theta 1 times sin theta 2 give us sin theta 1 sin theta 2. So you close the big bracket. Okay, what do we do next? We'll always recall that I square is always what? Minus 1. So we substitute. Z is equal to R1 R2, product of R1 and R2 into cos theta 1 cos theta 2 plus, there is present of I here, there is present of I here, factor I out, which is I into bracket cos theta 1 I sin theta, so which is cos theta 1 sin theta 2 plus cos theta 2 sin theta 1. Close it. Remember that this is minus 1. Minus 1 multiply this will give us minus sin theta 1. Theta 1. This is theta 1. Theta 1. Theta 1 sin theta 2. Sin theta 2. Okay. Now what do we do again? We collect what? A like terms. And like terms are what? The real part to real part and imaginary to imaginary. So which is Z is equal to R1 R2 into bracket cos theta 1 cos theta 2 minus sin theta 1 I 1 sin theta 2. Okay, that is in plus I into cos theta 1 sin theta 2 plus cos theta 2 sin theta 1. Close it. Okay, that is thing. So always remember trigonometric form of what? Complex number. Always remember what? Trigonometric what? Forms of complex number. We always remember what? Trigonometric forms of what? Complex number. Recall trigonometric identities that says cos into theta 1 plus theta 2 into theta 1 plus theta 2 is equal to what? Is equal to cos theta 1 cos theta 2 minus sin theta 1 sin theta 2. That is what the trigonometric forms of complex numbers stated. That cos into what? Theta plus theta 1 plus theta 2 is equal to cos theta 1 cos multiplied by cos theta 2 is minus sin theta 1 multiplied by sin theta 2. So we are going to look at what? The same thing as sin theta, where they say sin into what? Theta 1 plus theta 2. It's going to give us the same thing, cos. This is the same thing as saying cos theta 1 sin what? Theta 2. What plus what? Cos theta 2 sin theta 1. So having done that, we are going to replace them in what? In this equation. So this one will be here, this one. This one will be here, this one. We congest them. So that is how to do it. Are you true? So that we replace. Okay. Finally, what we have, that z is equals to r1 r2 into bracket cos bracket theta 1 plus theta 2, close it, plus what? I into what? I was plus I into what do we have here? Sine into theta 1 plus what? Theta 2. Close it. So, and that will be our answer. Finally, we can say, are you done? Are you through with this place? Are you through with this place? Okay. So let's have this. Finally, you can say somebody can say let R1 R2 equals to R3. Let the product of our two R's be equals to R3. Then we have finally that Z is equals to what? R3 into bracket cos bracket theta 1 plus theta 2, close it, plus I sin what? Theta 1 plus theta 2, close it, and that is it. So that is the proof of the what? The answer. So this is what we are going to make use of, and that is how we prove what? The complex what? The polar form of complex number. That is how to prove it. Finally, we have R3 into cos into theta 1 plus theta 2 plus I sin theta 1 plus theta 2, and that is the answer. Thanks and God bless you. Remember to subscribe to my YouTube channel, Prismatic Online Class. Bye.